Okay, perfect. So, hello everyone. Great that you're here. Such a great audience, such a great city. Happy to be here. Thank you for the invitation. Um, for the start, I have two good news for you. So, the first thing is that the movie, which is said to be fantastic, will happen, will be shown right here. So, you have the best opportunity now to take the best seat and remain seated. And the second thing is, um, that I'm probably also not going to take 40 minutes for the presentation, not do too many formulas, not do too many things about pipelining and everything. I think you heard a lot about that today. I'm going to, dig a little bit in a different corner because I'm also not a data scientist myself. I am coming from a statistics and marketing background, and I want to show you a tool that we developed based on NLP and neural networks that helps our clients to take insights for customer understanding. So the thing that we thought about at Link Institute in Switzerland was a lot of our clients are coming to us and asking us, we have so many pieces of information, we have so much data, we have so much, in our CRM systems, in our databases, so much information collected, and it's very, very hard for us to transparently analyze and interpret this information. And can you help us? And our analytics team developed a methodology which is based on the following problems on our client side. The first thing is, what we found was that most of our customers and most of the potential customers that we have tend to waste the qualitative feedback data that they have from their clients. So parts of those companies that we work for, they have tons and tons and terabytes of qualitative open-ended text feedback from their customers, touchpoint based, like per year maybe 100,000 comments that they gather. But they have the problem that they cannot really implement and really analyze and benefit from this data because it's complex, because it takes time, because one person alone cannot read through all of those comments and cannot understand and structure those comments. So what are they doing? They typically have them coded via NLP solutions or via manual coding. They do some kind of frequency analysis, and then they take this as a measure for customer feedback. But it's not good enough. And this is why we say about 90% of this qualitative feedback is wasted. Second fact and observation that we had when we started this approach was that we found that same as 30, 40 years ago, and the same as in the next 20, 30, 40 years, the questions that our clients have for us, they've always been the same, in a nutshell. They're always asking us, what is driving our sales? Why are our customers leaving our company? What makes our customers happy? What makes our employees happy? And these questions on causal effects, these questions on driver analysis and everything, they remain the same. And the companies really struggle with that. And most of the companies are still using very, very, very old-fashioned kinds of statistical analysis for that. Most of them use correlation analysis, regression analysis, very simple models. And these are not well enough. And there are much better solutions nowadays, as you all know. So based on that, based on the fact that they're wasting a lot of insight, based on a lot of data, and on the other hand, based on the fact that they still have the problem for these causality issues, we thought it would be good to build a solution based on machine learning algorithms that on the one hand makes use of what every company already has, which is on the one hand the NPS score or any other KPI, can be customer satisfaction, can be willingness to purchase again, can be likelihood of revisiting the store or whatever. So a quantitative measure on the left-hand side, and on the right-hand side the open-ended text feedback that where customers explain why they gave this evaluation. So it can be long text, short text, any language, any country, and any complexity. And these are the only inputs that we need for our tool and for our model that we developed. And we then have the process built as follows. So we have the We take the unstructured text feedback. We have NLP logic implemented in order to, or basically a tool implemented in order to have this coded, including sentiment analysis, which provides us with the categories, including evaluations. So we understand, okay, what kind of topics come up. And then we do the driver analysis, key driver analysis basically, which is based on neural networks. I'm going to dig a little bit more in detail on that in a few seconds. And explains the causal relation within the data. Explains what really drives recommendation, or what really drives customer satisfaction, what really drives employee satisfaction, for example. And in the end, since this is a pretty standardized approach, this means you can use it for any industry, you can use it for any product, you can use it for any country worldwide. We thought that we also need a kind of a standardized solution for visualization. So a tool that allows our customers to do self-service analytics within the results and to easily understand the results, because we can't provide them with neural network output graphs in n dimensions. That doesn't work. It has to be something that managers understand. So it has to be simple. And this is the final step. This is the explanation and prediction tool. And I'm going to show you those 3 steps, the NLP, the causal analysis, and the tool a little bit more in detail now. So for the NLP, we have all of those customer statements, all of these explanations, elaborations, what are they satisfied with or why are they unsatisfied, and we tried several solutions. I don't know, maybe you can just briefly show your hands and put your hands up if you had any one of you who would consider themselves expert in NLP and experienced in NLP. Okay, that's only 4 or 5. So what we did was basically to get an idea of what works well, we first did a manual coding of test data that we had, like 50,000 feedbacks that we had for a certain client, and we did the manual coding approach. So a person sat there, read through all of the comments, categorized into a certain categories that we defined, and also tried to manually categorize the statement. So does this client have a positive, a neutral, or a negative feeling and association and sentiment within this data? And we did, based on this manual code outcome, we did the analysis with the causal analysis in order to understand how well this data now can be used to explain the outcome variable, the recommendation. And we found that the manual coding works to about 68 to 72% accuracy. So the explanation power is between somewhat around 70%, which is pretty much in line with the scientific standards that are communicated. And then we said, okay, this is something we can do, and 70% explanation power is not bad, but it's a huge amount of work. It's so manual. It's tons and tons of data. It's countless hours of work, and we want to have this automated as far as possible by keeping a high quality. And so we tried, at the first step, we tried unsupervised learning solutions such as Lexalytics, Remesh, Google NLP. Some of you may know these, so that you put in the data, you get back, with unsupervised learning, you get back like categories, buzzwords that the software throws out and tries to identify. And we put this output and matched it against the manual coding output, and it was much worse than the manual coding. It only ended up at around 36 to 40% of the explained variance. So the accuracy or the explanation power within this data that came out wasn't well enough for us. So we tried TM in RStudio and NL Toolkit in Python. Tried the supervised learning solutions, which also ended up at relatively a better score, but they didn't perform as well as manual coding. And I don't know who of you has heard of the Caplina coded solution. This is a platform which has been developed in Switzerland, based on a thesis at the ETH in Zurich. It's nothing to do with our company. It's a completely different startup, and they have developed algorithms in order to do text mining and coding of open-ended statements of customers and employees. This is very specialized, and this platform works on unsupervised pre-training with tons and tons and tons of data around the world with Wikipedia and everything. So to get a basic language understanding and a context understanding. And then it also includes like transfer knowledge. It uses transfer learning basically from similar studies, from coding in similar industries, from coding on similar topics. And this really paid off because the supervised learning engine from Caplina really did the job for us. So this is no tool that we invented, and I mean it wouldn't make sense for us to develop it on our own because we can only code the data that we have ourselves. But the supervised learning engine from Caplina can of course code not only for our institute but for any other institute and any other customer and any other client, and have a much better learning effect on the algorithms. So this even outperformed manual coding in this test case that we did. Typically it's around 70%. Sometimes when the data is really complex, it's like an F1 score of 65%, but it's really good. It's working really well, and it's improving each and every year. And this is why we chose to opt for this Caplina solution for our tool. It's quick, fast, easy, and it's very accurate. And if you're interested in details on the NLP logic behind and on the learning logic behind, I will not get in detail on that because time is restricted, but if you want, there is links there that lead to the thesis and lead to the award that the algorithm won in Semivell 2016, where the invention basically also outperformed any other algorithm that was handed in for this task. Good. So the step one is done. We have the open-ended text feedback has been quantified now. We have categories. We have a supervised learning platform which works really well and almost as good as humans do. And the second step is then to do the causal analysis or the driver analysis or whatever you might call it. And as you all know, the thing that people always struggle with is to differentiate between correlation and causation, something everybody of you has probably learned within his first statistics course. But in real life, nevertheless, people tend to forget about that or tend to ignore the fact that there's a difference. There's a lot of funny examples on the web right now. I just picked my two favorites. Some of you might have seen that. The first thing is the correlation between mad cow disease in England and Brexit vote from 2016. Of course, this is only statistical correlation, not causation. And the second thing is that there's this strange coincidence between Google searches for erectile dysfunction, hair loss, and so on and so forth, and Trump voters distribution in the US. So, of course, this is, as you know, there is no cause behind. Okay? But what we want to do is, of course, be able with our analysis to differentiate between correlation and causation. We really want to find out which factors have an effect on others. And in order to do that, in order to be precise on the causal analysis, we really need to have a good and solid procedure. Probably can't read that. This is now a real-life example with real data that we had for Sonos. Who knows the brand Sonos? About every sixth maybe here. Not too many. So Sonos is at that time considered and is still considered as the world market leader for sound experience systems that work across multiple rooms. And so so the USP of this company was basically to have sound systems that work and can be Wi-Fi connected across rooms. And we took a look at the data they had, because they had client evaluations, and we did a correlation analysis based on the individual statements and based on purchase consideration for Sonos. And the effect of the correlation analysis shows that, you can't read it, but these two statements here at the bottom, they are basically referring to the multi-room capability. So they are basically referring to the USP of the company, which was quite frustrating because they thought that the multi-room capability was important to customers, and this is why they bought Sonos. But the correlation analysis showed that the facts, at least from a direct correlation, they're not so much important. And this is where we decided, okay, of course we cannot go with traditional correlation with bivariate or linear correlation analysis and regression analysis. We have to do something different. And we implemented basically USMs, universal structure modeling techniques. I don't know who of you has been working with them, but if you have not, and if you're somewhat into trying to find out about effects and everything, this is why we might have a look at, because it really works and it's really good. And the idea behind is that the first advantage is that you can also measure indirect effects. In this case, the multi-room capability of the Sonos has influence on a latent variable called sound experience that you can find out, which influences identification with the brand Sonos, and then strongly influences purchase decision, purchase intention. So actually it has a strong influence, but it's just not direct. And this technique helps you to find out about such, indirect causalities as well. And the second advantage of this approach is that you can also find out about nonlinear relationships. So this is the traditional approach. Oops. So you can see there's this regression model where you have like linear relations in between the separate variables, and this is the approach that we use based on neural networks, which enables you to find out about nonlinear correlations as well. Because in very, very many cases, in most of the cases that you actually have in real life, there is a saturation effect at some stage. In this example, you saw that there is a correlation or a causal effect in between how much you spend on print advertising, how much you spend on TV advertising, and how this influences your sales. And of course, the effect is not linear infinitely, but there is a saturation effect, and you can find out about such effects and such nonlinearities with the universal structure modeling technique. And the way that this works, just briefly, is that in the first step you build your model. So you use the variables that you have. You have, for example, the categories from the open ends, and you have the sentiments that you have within the data. And then you can also include latent variables. So you say, okay, there is some of those facts, they influence a fact called customer experience, and this fact cannot be directly measured, but some of those facts contribute into this latent variable, and this latent variable itself then has other effects. And so you can build a causal network, basically. Then you estimate the connections in between the network, and then after this analysis has been done, you get the graphs out. So you can do the interpretation of how these factors influence each other. How is the relationship? How is basically the network in between the variables, as I just showed as an example. And for quantifying the connections, of course, there's different techniques. And we tested many. We tested so many algorithms, and we found that the approach with using Bayesian neural networks work best, because on the one hand they avoid overfitting, and at the other edge they deliver results that humans can quite easily interpret. And this is why we use this technique to quantify connections in between and use the neutral approach in this case. And that's it. the explanation power of the approach of this USM, so Universal Structure Modeling approach you see on the right, is this is average score, so on average about 40% better than traditional types of analyses. And by including the sentiments that we derived from the NLP procedure, as I explained before, there's also indirect effects that you can consider, and there's also indirect effects by the latent variables that you can find out about. And this powers the causal analysis, this powers your insights in the end, this powers what you find out within the data, and leads to the fact that the explanatory power is much better. And this is the reason why we opted for machine learning technique, basically embedded within this universal structure modeling approach. So that was the second part. So now we have the first step. We coded the data by means of NLP using the Koplina platform. If you don't know it, you might have a look. It's really interesting and intriguing. Secondly, we used USM technique in order to find out about the causality within the data, find out what really drives customer satisfaction. And then, so far so good, but the output is nothing that any manager or any company can work with. So we thought, since this is pretty standardized and since we have a very good result, we also need to have a tool which is simple, easy, and which enables our customers to do self-service analytics with it. And this is, as far as we learned, one of the major barriers that these approaches often fail, because you can't manage to get the people actually work with the results. But we developed a tool, and we also developed a platform for it, called it Predictive Promoter Score, and also scripted a small dashboard that managers can quite easily use, or our customers can quite easily use. So on the one hand, you can see that there is a descriptive part where you can see the actual NPS, or the actual customer satisfaction score. You can see the trend in between the waves. And then there is also a key driver analysis, which reveal the outcomes of the causal AI that I just described. You can see how variations in between the waves are made up. So what drives changes, what drives improvement, what drives losses in the NPS. And you also have a small prediction calculator, which allows our customers, based on the driver analysis outcome, to switch in between the performance of individual criteria, and then they directly see how strongly this influences the NPS performance. So they get a feeling of how much can I actually improve? Where do I have the strongest levers in order to improve on customer satisfaction or on NPS scores? And what is the typical range that I'm limited to within my product or my company from a customer point of view? So, and here on the right hand side, these bars, they basically show the categories that came out of the NLP procedure. So these bars basically reflect the actual statements. And I mean, this seems fair enough, and this looks quite simple probably to you, I hope. But the question is, okay, where's the gold nugget? So why is this working? Why do many companies actually implement this? And this is quite a good chart. This is basically the key driver analysis output. And I made this a little bit bigger so that we can all have a look. And there it becomes quite striking what the difference between the old-fashioned and the new-fashioned way of interpretation is. Because in the past, most of our clients only referred to this axis when they analyzed their customer feedback, their qualitative customer feedback. As I said, it is being coded. They count the frequency of the codes. They count the absolute and relative frequencies. And for example, when you just look at this axis, you see great personal customer service is very important. Many customers say that the service is good. There they have positive connotations about that. Also, many say that the company is really professional and that advisors do a great job because it's great consulting. And of course, these facts are important. They wouldn't have been mentioned so often if they weren't. But the interesting thing is the second axis, because this reveals the output of the USM. It shows you how strong the impact is related on the positive and negative axis, basically. So the farther on the right, the more positive the impact of certain statements, items, and criteria are, and the farther to the left, the more negative the impact on the NPS. And you can see that there are hidden drivers that if you just look at the frequency of mentions, if you just look at how often people say something, you miss those because they are not revealed. And the machine learning based procedure has a very good accuracy on explaining the data, explaining the context, the causal relations. And this is why you see that, for example, in this case, trustworthiness, honesty, and so on, they pay in much more for improving the NPS than great consulting or professionality do. Also because the company is already very good at this, these aspects. So that is basically it. So this is the three-step procedure: NLP coding via Kaplina. Secondly, we do the causal analysis based on BNN by means of newsrule, and then we have the output more or less standardized in the data pipeline, which is coming into this tool, and this tool is being provided to our clients. And if you're interested in any details on the methodology, the models, and everything, don't hesitate to contact me. I can provide you with some literature if you're interested and have the time. So I can also tell this quite forcefully, because we know that this works really well. We tested it in many industries, and basically for many clients there is a very significant gain of insight within this approach. And if you consider back to the start, this is all based on data that's usually wasted and not really used within the companies, that they typically don't really make use of, throw away, put in the CRM system for somebody else to read sometimes. This is, I think, a pretty good approach, and of course pretty much automated based on machine learning algorithms. So thank you very much for your time and attention, and if you have any questions, let me know.